All right, welcome back, gentlemen. So this is a branch off of our last video on balancing chemical equations. In our last video, we saw this chemical equation. We had potassium chromate reacting with lead 2 nitrate, yielding potassium nitrate and lead chromate. Now, the reason we could balance it using clusters the way we did before, using those single units, was because these units that we talked about, the chromate and the nitrate on both sides, these are special. They're special in that they're what we call polyatomic ions. Polyatomic ions can be broken down in this way. Poly means more than one, or most of the cases we say many. Atomic is referring to the atom, and we know what ions are, charged atoms. So these are many atoms that act as an ion. Further explanation is this. A polyatomic ion is an ion composed of two or more atoms that are bonded together covalently that can be considered to act as a single unit. Most important part is here at the end. It's an ion. It's a bunch of atoms bonded together, and those atoms together act as one single unit with a charge. For example, chromate here is this, CrO4, and this whole thing has a charge of 2 minus. This is known as chromate. When we talked about ions in a few sections ago, we named them using an IDE ending. Polyatomic ions, most of them are named with an ATE ending. Our next example was this NO3. NO3 was a cluster of two nonmetals that were bonded together covalently, and they act as a single unit. So we have NO3. It has a charge of 1 minus. This is known as nitrate. And remember, this entire cluster here has a charge of 2 minus. This entire cluster here has a charge of 1 minus. We're not going to go into why, but they do. And the same is true over here. They haven't changed. This is NO3 with a 1 minus charge and CrO4 chromate with a 2 minus charge. Again, atoms haven't been created on this side, they're just being rearranged. And this is how we get our compounds here. So this might be jumping ahead a little bit, but you're ready for it. So, if we're going to talk about how does it become this complex looking thing, potassium chromate. Well, we know potassium has one valent electron. When it loses it, it's going to become K+. And we know, because I just told you, that chromate is an ion, a polyatomic ion, that is CrO4 2 minus. Just like in our other examples, when we talked about ions the first time and forming ionic compounds, here we can use the crossover method to create our chemical formula, the first one, potassium chromate. This understood 1 here applies to this entire single unit known as chromate. This 2 here applies to my potassium atom. If I write the chemical formula, it says that I have 2 potassium atoms and 1 chromate. This 1 applies to the chromate. That's an example of that. Now let's try a different example. Let's try this next one. There are parentheses here. Let's talk about why. So now, I have the 2 things going there. I have nitrate, which is NO3 minus. And I have lead, which is Pb. Lead has a charge of 2+. lead has given away 2 valence electrons, or 2 electrons. Now I do the same crossover method. This 2 applies to my NO3 cluster, and this understood 1 here applies to my lead. So when I write the chemical formula, I write it as Pb NO3 2. This is confusing looking. Thus, in order to state that we want 2 NO3 groups, just like we stated over here that we wanted 2 potassiums, we put parentheses around it to signify that we're talking about 2 NO3 clusters. And that's how you would make ionic bonds and write ionic compounds using polyatomic ions. This is going to be very beneficial for you in section 3. So try to understand this, take notes on it, and ask questions in class. Hope this helps, gentlemen. Peace.